This week,
this is one of the most incredible things I've ever done.
Paul's in California investigating artificial arms, which encourage the mind to power the prosthetic.
Alistair's tackling the tricky issue of head injuries in rugby. The secret may be in the mouthguard.
Shona's been speaking to the boss of the biggest genealogy platform, finding out what it technically takes to trace your ancestors.
And it's Oscars season. We talked to the creator of The Creator about its visual effects. No robots were harmed in the making of this programme, I promise.
Over the years on Click, we've seen lots of advancements in assistive technology for disabled people. One of the areas that continues to develop is prosthetics. New materials and innovations are making them lighter, cheaper and easier to use.
And Paul Carter's been to California for an exclusive first look at a revolutionary new type of prosthetic arm that's closing the gap between body and bionics.
Prosthetics have come a long way. From the early days of wood, tin or leather, to modern limbs made from carbon fibre and silicon. Once basic yet functional, they're now advanced and bionic. And here at Atom Limbs, I've come to see how the latest technology is bringing the next generation of artificial arms. They're developing a prosthetic with a full range of human motion that's using signals from the brain to control those movements.
The most advanced state-of-the-art prosthetics we control today is what you call myoelectric control. So that's putting electrodes on your stump or residual limb. And the difference between what you would do today with a state-of-the-art arm versus with an Atom Limbs arm is we basically cover your stump in electrodes, and you, when you first put the arm on, you take about 5 minutes and you train it up. And what that looks like is we say, all right, with your phantom limb that we can't see but that you can, flex your finger, extend your finger, rotate your wrist, rotate it the other way. And our machine learning and AI system takes a huge amount of training and spits out a result so that now you, whenever you think, can just move. So there's nothing in your head, nothing on your head, nothing in your arm. It's all this surface electrode and AI that basically powers it.
The arm is worn via a strengthened vest or shirt, which the arm connects to via an interface, reducing the need for custom-made sockets or the input of clinicians. Jason lost his left arm in an industrial accident in 2012. He's been working with Atom Limbs to test and develop their new prosthetic.
Tell me a little bit what this is like to operate. I mean, obviously, you're controlling this right now. You're moving this essentially by thinking about it. How are you thinking of that? What's the process that you're going through?
Well, just like with anything, with like using your regular hand, I'm still thinking about the motions, and I have a phantom limb. It still feels like I'm just moving my regular hand.
Yeah.
It's a little bit more difficult, obviously, because my muscles are tiny. With the TMR surgery, they've actually taken, you know, the 3 major nerves that are controlling your entire hand and integrated them into 3 different muscles. So now you're not flexing the entire muscle now, you're flexing just a portion of that muscle. And so there's a lot of concentration that has to go into making those movements. It's not as natural, obviously, as moving your regular hand. It's over time and just with practice, I think it's just become easier over the years.
Many existing bionic arms have a range of predetermined or programmable grips that the hand can perform, such as pinch grips or full fist. The Atom Limbs arm allows for individual finger control with haptic feedback.
So you're getting vibration or something from the arm that's telling you when you're gripping the glass?
Yes, exactly. When I reach in, I grab something and I hold it for a certain amount of time, right now already, just at that point it kicked in, and I'm getting some vibrational feedback here. So that's my indicator that I know that the hand is not going to automatically open and drop whatever I'm holding. And so that it's nobody else does that, and it's compared to my old prosthetic, there was always you had to constantly, I don't have to sit here and watch the baseball right here in my hand because I know it's got a good grip.
Although not an amputee myself, I was able to put on some sensors and try a digital twin of the arm via the control software. And it's safe to say, it was a hit.
No way.
within just a few minutes of training, I was able to perform several different motions and movements of the arm.
What the? This is phenomenal. This is one of the most incredible things I've ever done. The only way I can describe it is it's like on a games controller, I've mapped different buttons to different muscles that I've got here. So when you said like for the grip, well, I don't know what a grip feels like, so I just chose something that sort of feels vaguely similar, and that's the one that I'm using to open and close the hand, and the same for the elbow. Like the elbow one's a bit easier for me to do because I have that range of motion, so that's like the most natural one. But for like the grip, there we go, see? And then for the wrist is probably the most difficult one because I'm having to use a bit of rotation. This probably just looks really mundane to most people, but to me, this is incredible.
The arm being developed here is still at an early stage. The company are gathering data ahead of regulatory filings in the US. Of course, the biggest stumbling block for disabled people accessing new technology is cost, with the latest developments often being unaffordable except for those with deep pockets. Exactly how much the Atom Limbs arm will be is yet to be confirmed, though they claim the goal is to make it available at around the same price as a non-bionic arm in the US, approximately $20,000. As technology advances, the hope is that prosthetics in the future will become more affordable, more versatile, and ultimately, more intelligent.
That was absolutely amazing. That's the best workout I've ever had.
The Six Nations Rugby Union tournament is well underway, but there's something different this year that you might not even notice.
Yeah, players are wearing new mouth guards, which can detect the impact of knocks and bumps, and the data is then used in head injury assessments.
It's part of a rule change rolling out across all elite rugby union games, and Alistair Keane's been finding out more.
It is a tiny, tiny chip in what looks like a normal mouthguard.
Yes, it is. Essentially what it does is it measures head accelerations. So how much does your head move? Forward, backwards, rotational. It has a piece of technology in the left-hand side of the mouth guard, what we call the buccal cavity, and it's got some really interesting tech inside. So accelerometers, gyroscopes, proximity sensors.
We have now introduced these smart mouth guards into the head injury assessment process. So essentially, whenever a player sustains an impact or a force or a knock on a field that's above a threshold that's been pre-identified, an alert goes from the smart mouth guard that they're wearing to the match day doctor that's standing pitchside, and the player then will be removed and entered into the head injury assessment. So this is an addition to the process, because at the moment there are a variety of criteria that result in a player being removed for a head injury assessment, and those are typically observable signs and symptoms, so like the player looking a little bit dazed or confused or taking excessively long to get up off the ground.
Are you expecting more players to be taken off then during a game?
Yeah, so there's the fine balance that we have to reach between wanting to flag players for having significant knocks and bringing them off, but we also can't disrupt the game and have an excessive number of players coming off. So we expect, based on where the thresholds are set that we've based from data that we've collected over the last 2 years, we expect about 1 alert per match.
You have lots of players spread over a huge area. They're all going to have their mouth guards in, but you're still able to get that data back in real time.
Yeah, and the system's really simple. So it's a Bluetooth-enabled technology. So it works off an iOS device or an Android device. So as long as you're within range of the Bluetooth, which can be up to 50 meters, 100 meters, depending on the Bluetooth frequency within the arena, it will communicate and give you live data. So again, it will tell you if there's been a big head acceleration or the volume of head accelerations that have happened. What we're seeing with this type of technology, which is common in iPhones and all sorts of other electronics, is they're getting smaller and smaller. And we believe that this technology will just continue to get smaller. The battery technology is becoming smaller as well.
So I'm obviously a fraction of the size of an elite rugby player. I wasn't hitting anywhere near as hard as they do. Did it register anything?
In the background, it's picking up the tackles, but for our application, it has to hit a certain threshold, and you didn't reach that, which is great. I've got some examples here, though, of what this might look like over the course of a season for a professional athlete, if you want to have a look.
Yeah, let's do that.
You can click on the individual events themselves, and you can actually look at where the individual received the impact.
So from the mouth guard, it can detect where the head was hit.
The mouth guard's connected, is on the teeth, which is connected to your mandible, or cranium, sorry. So it can detect where on the head or on the upper body that the actual impact came from.
This comes at a critical time for rugby. Scores of former players have launched legal action against governing bodies over the long-term impact on their health from playing the game. But it's advancements in technology that make this new monitoring procedure possible, and officials hope that will make the game safer. There are voices from experts and former players who say actually the game should be changing. You shouldn't just be introducing these mouth guards. You need to stop the big hits from happening. Is this enough?
That is a hard one because rugby is a contact sport. There will always be an element of contact to it. So what we need to do in our roles in the player welfare space is try and make that contact as safe for players as possible. So ultimately this technology, it will lead to changes to the game and changes to the way players train. But now we need to collect data from players over a period of time to then really understand what the game and training looks like for these players, and we can then make changes.
You're going to gather all this data. Once you have it, is there actually an appetite, though, to react to it and change the game?
Absolutely, I would say without a doubt. We've had incredibly warm and responsive responses from teams and from players and various coaching staff. I don't think anyone would deny, or largely everyone would acknowledge, that the game needs to continually try to make safer, and we need to reduce this impact to players. So absolutely everybody is on board with it, and I think we have more power behind it by it being based on evidence and by it being objective, because a lot of rugby and a lot of monitoring contact and impact in rugby is very subjective. What I standing on the field might look different to what you, or perceive to be a different level to what you standing on the field, but then also different to then what the player's actually experiencing. So by now having these numbers, everyone says we need the data to drive the change. But yes, the desire is there for sure.
This is still new technology being used on this scale for the first time. There's going to be continued scrutiny of the data it collects and how that informs the debate on changing the game.